Well, hello to my students, and this is the beginning of our unit on atomic structure. Just a reminder, I assume most of you are watching this during class. Make sure you have your sound on so that you can hear what I'm saying. Just watching what's on the screen is not going to be enough because I'm going to share some things that you're not going to get if you're not listening. The captions are not going to work. I would suggest you enlarge this video, so hit the button in the lower part of the screen that blows this up to fill your screen. If you're watching on your Chromebook, those are pretty small to begin with. That way you can see things a little bit better. So we're starting in a unit here which basically, if you could describe what it is, it's like, what is all the stuff in the universe made of? That's really a short description of the entire semester. What is all the stuff in the universe made of? And you've probably seen this before. This is one way to answer this question. What you're looking at here is a little section of the periodic table of elements. And so one way to answer that is all the stuff in the universe is made up of these 118 different elements. As of the time when I'm making this video, there are 118 elements on the periodic table. You may be watching this later. We could have discovered another one by that point. So we're digging into what makes these elements unique. Like, why are some of them called titanium and some of them called sodium? And so that's going to be what this unit is about. So we're going to start with this sort of basic question, and that is, what is an atom? An atom is the smallest piece of an element. Remember, you can pause at any point. If I start to talk again and you're still writing, just hit the pause button, get caught up, and then continue, hit play again. So if we take all the different things we can imagine in the universe, all the stuff, and we start breaking it down smaller and smaller and smaller and smaller, you have to imagine this because you can't actually do that. Get these microscopic tweezers, if you will, and break them down smaller and smaller. At some point, you're going to come up with little pieces called atoms. And each of those atoms is a different element, as I was pointing out. If you break it down even further, you no longer have that element. Okay? You can break atoms down further. We call those subatomic particles. All right? And so all atoms are made of these. And they are listed down here on this table. They go by 3 names. There are only 3 things inside every atom. There are some protons, there's some neutrons, and there's some electrons. So what makes atoms different from one another is how many of each of these subatomic particles they have. Okay? So we're going to get into that a little bit further, but let's describe, okay, well, what makes these subatomic particles different from each other? And they can be different really in 3 ways. Their mass, like if we could imagine putting them on a little balance, a scale, which again, you have to imagine this because these are way too small to actually do that. So they have different masses. They have an important property called their charge. It's hard to define what that is, but I'm just going to describe it to you. And then there's a location within the atom, and there's a little picture here that's going to help us with that too. So let's just finish this table first. So the mass of a proton is about 1. Now I'm going to introduce a unit you probably never heard before. Atomic mass unit. That's a convenient way of describing the mass of these tiny, tiny little things. We wouldn't want to use grams or kilograms because they're just way too small. And we get these tiny, tiny little numbers. We'd have to use scientific notation. It would look messy. Okay? So the mass of a proton is about 1 AMU, and a neutron is also the same. But an electron, and this is very important to know that electrons are very different in their mass. They are almost 0 mass. I say almost because they do actually have a little bit of mass. It's about, you ready for this? About 1/2000th of an AMU. So these two masses these things are 2,000 times bigger than an electron. So when we look inside an atom, all atoms have mass because they have protons or neutrons in them. And the mass is determined by those protons and neutrons, but almost none of the mass is determined by the electrons. Okay? All right, and then important characteristics called charge. We describe the charge of a proton as positive. We often just put a plus there, but I'll write the word as well. That means positive. Neutrons are neutral. That's why we call them neutrons. Neutral means they have no charge. And electrons are negative. That's why I don't like hanging around electrons. They're always negative all the time. That's just a little science joke. Okay, so we'll learn more about these later too. And then I'm going to use this diagram to kind of describe this, but there are two different locations that we find the subatomic particles. The protons and the neutrons are both found in what is known as the nucleus. And so, while we're at it, we'll just go down here to this figure. The part that we're showing here in the center, that's the nucleus. All right? And so it contains, I don't know if you look carefully here, there's two different things. There's some of these plus-looking things. Well, those must be the protons. So we'll put a label on this here. That's pointing to a proton. And then the things without the label on it, those are the neutral neutrons. Okay? Now, I need to tell you that this is greatly exaggerated in size. So I'm going to put a note here that the nucleus is much smaller than shown here. If we were to show it real size, we wouldn't be able to see it. So I had to blow it up to be able to label the protons and the neutrons. Okay, and then the electrons, the little negative things, going to turn out those are awfully important things. They are located in what's known as the energy levels. And we'll dig more into the electrons and the energy levels in part 2 of this unit. But what you see out here, these little rings are called energy levels. So I've got 2 of them in this little picture here. There's some atoms that we know of that have up to 7 different energy levels. But this particular atom only has 2. And all the little dots here, there are 7 of them. These are called electrons. We'll learn in part 2 of the unit, like, how many electrons should we draw in each of these energy levels. Okay, again, pause here if you need to catch up, and then continue to play. Okay, we're going to use a couple of terms a lot to describe atoms. And there's lots of different ways to talk about their differences, but 2 important ones are every atom has an atomic number and a mass number. Okay? The atomic number is equal to the number, you're familiar with that symbol, I hope, the number of protons. So as soon as we know the number of protons in an atom, we know its atomic number. Now I want to point out here, back to our periodic table, every box, all 118 different boxes here, has a whole number at the top of it. My camera's focusing, there we go. So, and they go in order. So here's 1, way over here is 2, and then we continue on 3, 4, here's 5, 6, if this thing will focus, there we go, 7, and so on. So they go in order. Those are the atomic numbers. So I want you to notice that when you see a periodic table. Now, not every periodic table is laid out the same way. Sometimes the atomic number is in a different spot on the box. But it's always a counting number. So you go in order, 1 through 118, or whatever periodic table you're using. It might have a different number. Okay? That's the atomic number. Every atom also has a mass number. This is equal to all the mass. Now, up here, I want to remind you that the mass in an atom is due only to the protons and neutrons because the electrons are so small. So, the mass number is the protons plus the neutrons. There's a little math problem you got to do. Once you know how many of each thing is in an atom, just add up the protons and the neutrons. You will have that atom's mass number. Okay? All right, again, pause if you need to, but we're turning the page. Or in my case, I'm flipping the page. All right, the name and the symbol. All right, back to our periodic table. In every box, there's a big letter or two, or sometimes three, and there's a name. A little hard to see on mine. That's what makes each element different from the other. They each have their own special name. They each have their own special symbol that goes with that name. Usually the name and the symbols are kind of similar, like here lithium is Li. But sometimes they're different, like sodium is not So, it's Na. That's because the original name for sodium was in a different language, Latin. So it has a different symbol. So we can match up each name and symbol with the box that it's in, which also means it's related to its atomic number. So how do we determine the name and symbol we give to an atom? We match it with the atomic number on the periodic table. So you must have a periodic table in order to know the names. You will always have access to your periodic table in my class. There are some teachers who, for some reason, make students memorize periodic tables. I think that's silly. That's a waste of brain space. You will get comfortable with using the periodic table as we use it more. Now, when you take a chemistry class, there are so many elements that you use so commonly that the teacher doesn't want you looking everything up. That's why they might make you memorize some of them. I can't imagine memorizing all 118. I wouldn't be able to do it, that's for sure. All right, is an atom's mass number found on the periodic table? So I said back here on page 1 that the atomic number is the number of protons. That's on the periodic table. Here we are. The mass number is the protons and neutrons, but that is not on the periodic table. Okay, so that's an emphatic no. Students mess this up all the time. In fact, I see teachers mess this up. So let me show you what gets confusing. There is a number on the periodic table called average atomic mass, but that is not the same thing as a mass number. Okay, so it turns out there are different kinds of hydrogen. They all have an atomic number of 1 because they have 1 proton, but they don't all have the same mass because they could have different mass numbers. So I can't tell looking at the periodic table what particular kind of hydrogen I'm looking at. All right, so do not try to find the mass number on the periodic table. You'll mess that up probably. I'll have to fix it a couple times for you, but then you'll get used to not doing that. Okay, how about the electrons? Is that related to the name or the symbol? So the short answer is no, but, and this in my class will almost always do this. Most atoms are neutral atoms, which means electrons and protons are equal in number. Oops. Sometimes my pen gets ahead of my brain when I'm trying to talk. So neutral means that the protons and the electrons are equal in number. Let me go back one more time to page 1. Neutral means that you have as many positive charges as you have negative charges. Okay? The number of neutrons makes no difference here because they don't have charge. But when we balance out the pluses and the minuses, we call that neutral. And that's why protons and electrons are equal in a neutral atom. All right? There are times where you can have more of one than the other, but we're not going to be dealing with that for a while. Okay, I want to introduce you to the term isotopes. It will make sense now that we've described how atoms are different. Here are some diagrams describing the difference between a few different kinds of carbon atoms. Now, they're all carbon, which means they have an atomic number of 6. Here is carbon on our periodic table. Element number 6, we call it. That means atomic number 6. But there are 3 common types of carbon atoms. They're called carbon-12, carbon-13, and carbon-14. All right. There are 6 protons in each of them, but the reason they're called by different names is because some have 6 neutrons, some have 7, and some have 8. Okay? So, here's what isotopes are. They are the same element, which means, here I'm going to do this, the same element, they have the same name, they have the same number of protons, but they have different neutrons, and therefore different mass numbers. Again, what we're looking at here, protons and neutrons, when we add those together, that's called the mass number. And so we include that mass number with the name when we're talking about the name of a particular atom. If we put the symbol for a particular atom, we put that mass number up here in the corner like we did on this carbon-12, carbon-13, and carbon-14. Okay. So we indicate this with the mass number included with the name and with the symbol. I'm going to show you a couple examples of this because you'll be doing this on your first assignment. Okay, so we've been through a lot of information here. Let me kind of show you a neat way to summarize this, and this is what I'm going to have you do a lot. Actually, a lot of tests and quizzes will have things just like this. I'm going to give you some information about a particular atom, and you're going to give me the rest of the information about it. Okay? Now, if I don't specify, always assume that these are neutral atoms. Okay? I'll just put that up there to remind us. I'll show you in a minute when we use that. Okay, so if you know the name, remember you have to have a periodic table nearby to be able to find the name. And this can be frustrating when you're new to the periodic table because it's not like it's in alphabetical order. It's in order of the atomic number. So you have to search around, but I'm going to help you. So here's potassium. It's another one of those that has a symbol that doesn't match the letter, the first letter of the name. Let's see if we can focus here. There we go. Here's potassium. Okay, so I want you to kind of focus on this. See this 19? Remember that's called the, here it is in this legend, the atomic number. The number down here, the 39.10, that's not a number that we need. That's called the average atomic mass, and we're not going to be using that for anything now. You're going to use that a lot when you're in chemistry class. You won't use it much in my class. Okay, but for now we need to know that the symbol is K. The atomic number is 19. All right? Because here's what I want to do next. I want to put the symbol here, K. In Latin, this was called kalium. That's why it's K. And we also want to include the mass number. As I pointed out here, the mass number gets included with the name and the symbol. We put it in the upper left corner in my class. That's a 40. Now, in other classes, other teachers, other textbooks, you might see it put it a different place. It's not a real standard thing. All right. Now, let me remind you of a few things. If we know that it's potassium, and we found it on the periodic table here with number 19, that is the atomic number. So let's fill that in now. And that number 40, remember when we include it with the name and the symbol, that is called the mass number. So we're going to put that in as well. So we've already started to fill in some of what we know about this. All right, let me remind you too, the atomic number is equal to the number of protons. So if we know the atomic number is 19, we know that the protons is also 19. I now want to remind you that I said all of our atoms on these charts are going to be neutral. That means that the protons and the electrons are equal in number. Okay, good. So our 19 protons is also 19 electrons. Now here's the part that confuses students the most, so listen carefully here. We're going to do a little math. I tried to make the math easy. If you want to use a calculator, you can. But this mass number is the mass of all the protons and neutrons in the atom. All right? So if we could see what this atom looked like, we'd have a whole bunch of protons and neutrons right here in the nucleus. I know that 19 of them are protons. The rest of the mass are the neutrons. And a mass number is the total of all of those. So 19 protons plus some number of neutrons has to make a total mass number of 40. So what number do you need to add to 19 to make 40? You figure that out from subtraction. 40 minus the 19 protons. The rest of it then is the neutrons. I will do that math for you. It's 21. You can check me on that. 21 and 19 does indeed add up to 40. So we have completed everything we know about this atom. And all we started with was the name with the included mass number at the end. Isn't that clever? Okay, let's see how we can go in a different direction. Sometimes I'll give you just some numbers, like the protons and the mass number, and I'm going to have you fill in the rest. All right? So, there are important facts that you need to have in your brain. Remember that the atomic number is the same as the number of protons, which means if I give you the protons is 7, that also means that the atomic number is 7, so we can fill that in. And remember, we're dealing with neutral atoms. Neutral atoms don't have any more pluses than they have minuses, or no more minuses than pluses. The two charges are balanced. So that means the electrons also has to be 7. Okay, let's finish up the numbers. The mass number, remember, is the total of the protons added to the neutrons. So what number here has to add to 7 in order to get 16? That would be 16 minus 7, or 9. Okay, now let's go to the name and the symbol. For this now, remember, you have to have the periodic table nearby. We know that there's 7 protons, which gave us an atomic number of 7. And remember, that's how the periodic table is organized, in order of atomic number. So we just go across the top, 1 and 2, and then the next row has 3, 4, 5, 6, 7. And there it is, atomic number 7. Right here, it has the name nitrogen, and it has the symbol N. But remember, the symbol and the name are not particular to any special atom. That's just the symbol for all the different kinds of nitrogen, or the name for all the different kinds of nitrogen. We're dealing in particular here with nitrogen 16. So when we specify which isotope, we call that an isotope. It's a particular name that we give based on the mass number. Okay? So, come on, focus here, camera. See if I can help. There we go. So they will all be called nitrogen. Look up the spelling on the periodic table. Don't try to guess. Some of these have complicated spellings and you're not going to figure them out without looking. We add the mass number at the end of it, just with a little dash. And we do something similar with the symbol, except we use that symbol, and then in the upper left, remember, is where we put the mass number. And I want to mention now, too, because I don't think I mentioned it before, you must be careful to write the symbol just exactly as it's written on the periodic table. What I mean by that is, notice they all start with a capital letter, but that's the only capital letter in it. If there are more than one letter, let's say like here's aluminum, this is AL, not AI. The second letter, here's silicon with S and then a lowercase I. A bunch of these here in the middle, These have 2 letters as well. That second letter is always the lowercase one, but the first letter is always capitalized. Okay, so just a little detail that's important. In science, a lot of the details are important. Okay, so at this point, you're welcome to go back and replay anything that you need to. Remember, the goal here is not to just finish writing. The goal is to assimilate into your brain and into your memory what I went through here in this 25 or so minutes. I will sign off that these are done. You just have to call me over, or I'll maybe come by the room and I will check and sign off on my grade card that you have finished this, and I will write a little number 3 at this point here. That's for me to write on, and then we'll consider the notes done and your grade is done. But you're going to use this information, so keep it nearby. As you use it, you're assimilating it into your brain, hopefully. Sleep on it a little bit. That helps assimilate it into your brain. And then you will be smarter in the way of atoms than you were before. Okay, that's going to do it for now. Thanks for your patience, and we'll carry on.